Okay, so we have described the volume that this integral represents, and this is, we're comparing with the cylindrical shell method. So 2 pi, note that it's in terms of y now. So the radius will be y, and we have a height as a function of y. Okay, from A to B. Okay, so the radius clearly is ranging from 0 to 2. Okay, 0 to 2. And the radius is along the y-axis now. Okay, so it's going up and down like this. And so look, if you compare, we have 2 pi, so this 2 pi is same as this. And you can say that y right there is same as this one, which leaves the height as a function of y to be 1 over 1 plus y squared. Okay, so this is okay, let me let that be x. Let me switch the x and y. Okay, so some of you may know, okay, that this is a graph that looks like this. Okay, because 1 plus x squared is strictly positive, it never goes below the x-axis. Okay, and it's got an asymptote as the x-axis. Okay, it looks something like that. Now it's this right here is the inverse function of that, so where the x and y is switched. So instead of looking like that, okay, let me erase that a little bit like that. It's gonna look like this. It's gonna start from here, and it's gonna go down like that. Okay. So it's this from 0 to 2. So let's say up to there. Okay, so we're talking about from there to down here. That rotated, okay, this rotated about the x-axis. Okay, so it's edged off right there. Like that. So it looks like a little sand dune kind of on the sideways. Okay. A typical cylinder, if I were to draw a typical cylinder here, will look like this. Okay, where that right there is the radius, and radius is just the y, and this right here is the x, right? It's the x of this function. So that's why we're using that as our height as a function of y.